At this stage of the game, you've been introduced to the Python language, and now you are familiar with the language in which you have Turing completeness. This means that you are able to solve basically any computing problem that's possible to solve on your computer, provided you have sufficient time and memory. Now what we're going to do is we're going to study a second language, Java. And you're going to see that there are important similarities and differences that exist among these two languages. To get started, we'll talk about how Java works. And let's just talk about Java at a very mechanical level for now, just so you are able to write a simple program and see it run. I strongly suggest that you have Java already installed, which is simple enough to do. If you go to adopt.jdk.net, you can download the appropriate stuff to make Java work. Now, let's go ahead and get started. So, when you program in Java, it's going to look something like this. I'm going to make a file called hello.java. And you're going to see a whole lot of new things happen. You'll notice that my editor turned those two words green. That should be a cue to you that they are special language keywords. Public has a simple meaning. It means visible outside of this file. Class is a means by which you organize programs. And we will see that both Python and Java have classes, and we'll see how to make classes in both. So you say public class. Now, in Java, there is a rule that if you call a file something.java, that the public class inside of it must have that same name. So inside of hello.java goes hello. If you do not have those two things matching, you'll get an error message early on. So inside of here, I'm going to put a special method, and it's going to have a lot of intimidating keywords. And we'll eventually understand what they all mean, but right now it's not that important, so don't get bogged down in it. This is kind of like your main method in your Python program. This is the method in which Java begins execution. So I'll make a comment here. You know what a comment is. Here's a one-line comment. I'm going to say Java starts executing here. All right. In this method called main. And it's got this very special name. You need to type this pretty much exactly as you see it. Okay. Now, inside of here, I'm going to say system.out.println. Ew, that's kind of ugly. Well, I'll show you what happens in Python. And we're going to make the classical hello world program just like that. Okay? And here in a comment, I'm going to say .out puts things to standard output. Hey, that's just like print in Python. So there's nothing scary there. It's just got a bigger name. Okay, and I'm missing the letter T here, so I better do this. Okay, I've made a Java program. This Java program will execute. Now, to make that happen, you now type the command javac. Javac is going to undergo a process called compilation. This program will be compiled. Now, we'll see what that means in a moment. Okay. You'll notice that this folder originally was empty. We created hello.java. Javacking, or compilation, produced a file called hello.class. This file is not human readable. If you attempt to open it with your text editor, you will see gibberish. However, if you're running on a Linux machine, and you want to see what's in here, that's what's in here. Much of it is not human readable. You can see over here, this is what's called a hex dump. All right. And the characters over here correspond. Each character here is a hex number. A hex number is 2 bytes. So each of these, you can see that each of these characters, a lot of them are not readable. And this is pretty much unintelligible. What this thing is called Java bytecode. Now, when you install Java, you install a virtual computer on your computer. There's a computer and software, and the name of that computer is the Java virtual machine. Now, the reason that you can run the same program, you can type the same code and run that code on a Windows machine, on a Linux machine, on a Mac, and it runs in the same manner, is all 3 of these have different Java virtual machines. So what the Java virtual machine does is it will take your Java bytecode, translate it into the machine code for your machine, and run it. Now, we've done the first step. We've compiled and created Java bytecode. Step number 2 is running. And here you just say Java, hello, omit the extension, and voila, your program runs. Now, if we make the same program in Python to do the same thing, I'll do that right here. You'll notice a difference right off the bat. And that difference is you are not required to enclose your code in a class. Okay, here's our main routine. This is simply going to run. Okay, and now that runs. Now the compilation process is more complex. And there are ways in which it can simply fail. And I'll show you how to make it fail a really easy way. Here's how you make it fail. And now all of a sudden, it's coming up. Let's go hello.java. Watch this. Now you'll notice this is basically print hello world. Hey, that's a complete sentence. That statement is a worker statement. I'm going to go to the end of the line here, and I'm going to get rid of its semicolon. Watch what happens. Uh-oh. Now, let's do this. Let's remove our... All right. I'm going to remove that file, and I'm going to recompile this program with the error in it. You'll notice that you do not get a file with bytecode in it. If compilation fails, you'll get an error message, and this is telling you right here, 1 error, semicolon expected on line 7. Hey, let's go and check that out. :7, wham! The error messaging in Java is pretty good. Sometimes it depends on the type of error. Sometimes it's not so great. So let me restore that semicolon. Okay, so you can already see an important difference between the 2 languages. A couple of important differences. 1, all code in Java has to occur inside of a class. 2, if you want to run the code, you need to have a main method. The main method will execute the code. Now, one thing you'll see is that when we start moving along here, we may have a program that consists of several classes, only one of which might have a main in it, but that one class may reach out to those other classes to help it do its job. Okay, so now we can see what the mechanics are of writing a Java program. You do the following things. And here I'll make some comments at the bottom. Step 1. Edit your code. 2. Compile. What are the possibilities here? If compilation fails, read your error messages. Remediate your code. All right? Otherwise, what will happen is you'll go, okay, and you're dead. If compilation fails, no bytecode is generated. Okay? Step 3. If your program has a main method in it, run the main method. Oh, you can run it. And omitting the extension. You'll see me do this about 1 billion times, okay? Compile. And how do we compile? We use Java-C. So, you edit, you compile. If the compilation fails, you have to go back to step 1. Edit the code. Okay? Once it compiles, if you have a main method in it, you can run it using the Java command and omitting the extension. Okay? So this is the mechanics of writing the code. And it also tells you something about what's happening. What is happening is when you compile your code, you're generating machine language for the Java virtual machine. Now, you have more than one virtual machine. If you've installed Java, you have at least 2 virtual machines in your computer, and possibly even 3. Java has a virtual machine whose code is Java bytecode. Your browser is a virtual machine. It understands 3 languages: HTML, CSS, and JavaScript. So that's another virtual, and Python also has a virtual machine. Now, one important difference between Python and Java is Python programs run, and they run until they fail. Whereas a Java program, if there is a logical flaw in it, it's entirely possible that compilation won't occur. But even if compilation does occur, your program could still have a variety of things that are wrong with it, and we'll learn about those as we go along. So these are the basic steps for creating a Java program. Now, the next thing we're going to do, and I'm going to go ahead and bail out of here, all right, is we're going to learn about the Java type system. And you might ask, well, you might have observed that Python has this handy little gadget here. If you type Python and no file, look, you have Python running. So this interactive shell is sometimes called a REPL. Read, evaluate, print loop. That's what it does. It reads, evaluates the expression, prints out the result, and that just goes around and around and around and around. Okay? Until such time as you hit Control D. So we're going to learn about jshell, and jshell comes with any version of Java 9 or later. Right now, and this is December of 2020, December 29th of 2020, Java is in version 15. So jshell's been around for a pretty good while. Okay, so to invoke jshell, all you do is type in your command window, type jshell. Now it'll take a moment to think, and there we are. So jshell has some useful commands, and I'm going to point out some of them to you. One is you can type help, and it will give you some basic information on things you can do in jshell. Okay, you can do this. You can type imports. Python, like Java, has importing, and this tells you what things are imported into your session. You can type /open and then a file name, and that file will be read into your jshell session, and we will see that. Okay, so those are some of the basic commands. There are several others. There is exit, help, imports, list, open, types, and vars. Vars shows you all of your variables. So far, we haven't created any, but we'll use these as we go along. Now, to get out cleanly, there are two ways. You can type this, but I'll hold off on that and hit enter, and that will exit it. Or you can use Control-D in Mac and Linux, or Control-Z as in put to sleep in Windows. And those are ways that you get out. So now you can see jshell. So we're going to see now how we create a variable, and we're going to learn about a couple of very basic types. The most basic type in just about any language is integer. Java, integer is called int. And you say int, then you say the name that you want to give the variable. Now, variable naming rules are the same in Python and Java, and they are as follows. The initial character can be alphabetical or an underscore. Subsequent characters are alphanumeric or underscore. So I'm just going to say X here because I'm just making a very simple integer variable, and I just made X. All right. Strings are present, and you just say string. Now you'll notice when I type this, I'm saying something interesting. I'm saying X, not just X gets 4 as I do in Python, but I said int X gets 4 because variables have types as well as data. Data have types, but variables have types too. And the type of a variable is fixed for that variable's lifetime. So once you are an integer variable, you are an integer variable for good. Here, I'll make a string variable, and you can do this, and that looks just like Python, doesn't it? Okay, so there we go. String, all right. Here, I'll make another variable, x equal 15. Now when I type /vars, I can see that. Oh, I updated x. I meant to make a new variable. Z is 15. And I'm going to change x. Now you'll notice once I make the variable, I don't repeat its type. All right. And I'll put it back at 4. And now I'll go. And you can see it's going to show us the symbol table we have generated for this session. So we have 3 variables, y, x, and z. And they are spaghetti. Y is a string variable. If I attempt to assign y equals 5, you see that? You cannot assign a datum of one type to a variable of another type. If you do that, you will get an error message. Now, in a compiled program, this would be a compilation error. So Java programs have 2 epochs in their lifetime, whereas Python has 1. In Python, everything occurs when you run the program. In Java, certain things occur when you compile, and those are called compile time events. Passing a variable a datum of the wrong type is a compile time error. The compiler will catch it. And that's probably a good thing, because otherwise, if you were able to do that, it might cause a logic error at runtime. It's going to be more difficult to ferret out. So the discipline of a compile time language can actually be a very good thing. Now you can evaluate expressions as well. Read, evaluate, print loop. If I go x times z, what it does is it fetches the values x and z off the symbol table and evaluates them. And that's just like Python's interactive mode. It's exactly the same. Now let's do this. Ooh, it created this cache 6 variable. So in addition, jshell will create these local variables that are equal to expressions that are a result of evaluations. And you can even call it back. You can go like cache 6 times 4. And see, it says 240. It's a legit variable like any other. Now, in the actual programming language, you'll not see this. However, in jshell, where you're experimenting around, yes, you will see this. Okay, so now what we're going to do is we're going to exit jshell. So I'm going to exit it by typing /exit. And we're going to make a class. Boom. Okay. All right. Public. Oh, wait a minute. I need to actually open the editor. So I'm making example.java. So here we go. I'm going to make, now, let's explain a little more about functions that are in classes. Functions that are in classes are called methods. Now, Python has functions that are not inside of classes, and they're called functions. Python has methods too. And in fact, we will build a Python analog of this program, and you will see some things that happen that are common to both languages. So let me go ahead inside of here. Okay, that is a worker statement. I put a semicolon at the end. Notice a method header is a boss statement. Okay, and this means to define, think of it for now as to define the function go, just as in Python. Here, to define the class example. All right, no mark at the end. Now, on the second line here, I'm going to go. I'm even going to be a little adventurous here. I'm going to say x equals all right, print f is formatted printing. And so what will happen is this x will be dropped into that placeholder and turned into a string. So everything prints out nice and pretty. Okay? And you can see string literals go inside of double quotes. By the way, they do not go inside of single quotes. They go inside of double quotes only. There's a difference in the languages right there. So it appears that, I don't have a main method. So it appears that this program can't be run. But we're going to go open jshell. That's why God invented jshell. So let's open it up. And now you say open. Look at that. We have written a class called example. Okay? So you might wonder, how do I run this? Well, what I need to do is make an instance of this class. And to do that, you say example equals new example. Because a class is a blueprint. Example, I need to put a name here, E. Okay, so I just created a new example. And that's how, and you can see some stuff echoed back here. This is what happens. I'm going to go ahead and do a system that out. Print on a V. There's your representation of example as a string. Looks terrible, right? Yes. We'll learn how to dispatch with that. But for now, we've made an instance of this class. Now, let's go ahead and inspect the go method. You just say e.go. And look at that. It printed out x is equal to 5. Okay? Printed out x is equal to 5. Now, what we're going to do next is we're going to make exactly the same class in Python and see the same kinds of things happen. Okay, so let's go ahead and type exit. And just for fun, we'll read our program in here and we'll turn it into Python. First of all, we don't need the word public. We don't need this curly brace. All we need is def go. Get rid of that. Get rid of that. Get rid of that. Now, the other thing I'm going to do is I'm going to say print. I'm going to turn this into a format string. And I'll just go like that. Okay. I'm making exactly, precisely the same thing. All right. So here's my class example. Oh, class example. That's a boss statement. It needs a colon at the end. So to define class example, we define go. And it's also a good idea to do this when you're working in Python and you're making classes. Put the word object in here. Later on, you'll learn why that goes there, but just do that for now. Okay? So we have a class. It's got one method in it called go. And the other thing we need to add in Python is this. And we'll talk about self later. You'll see exactly what it is. But just be assured you need it. All right. So I'm going to go ahead and exit this. If I try to run it, oops. Oh, I still have the int in there. Let's get rid of that. It runs, but doesn't do anything. Okay. So I'm going to open Python. Okay. From example, I'm going to import the example class. And now I'm going to say e is equal to, there's no new keyword here. So you just go like that. Bam. There it is. E.go. Does exactly the same thing. You can see the same kinds of things are happening here. Okay. So what can our example object do? It has one capability. It knows how to go. Now, you might be wondering what is going on behind the scenes here. What's the purpose of this class mechanism? The class mechanism allows you to create custom objects to do jobs that you want them to do. So now let's summarize what happens in mechanical level in Java so you know about it. Control D. Here, I'll write some notes here. So, to do Java, you edit, right? Compile. And then you run. And you test. Not, back to edit. Okay, so this is the basic cycle. You edit, you compile. Okay? If the compile fails, you go back to edit. If it doesn't fail, and you get a .class file, and it's got a main in it, you can run it. If it doesn't have a main in it, you can open it with jshell, and you can inspect it. Okay? So you have this edit, compile, run cycle. Now, let's talk a little bit about Python classes and objects as opposed to Java classes and objects, because it is a somewhat different ball game. Okay. So I'm going to make a class here. Actually, I'm going to make a class right in interactive mode. So I can do this, watch. Class simple. Okay. What does that do? Well, what does our object seem to know? It doesn't seem to know anything or do anything, but we can create them. We can go like this. All right. Even if you print it, it tells you you have some kind of simple object sitting at that memory address. So we created two what are called instances of the class. Now, you can do this in Python. There are things you can do in Python that you can't do. Look at this. S.x is equal to I am x. S.y. G. Yes. So this is an example of what is called stick building objects. But T.x, there's no such thing. So I only attached them. I made two objects, okay, and they don't have very much going for them. And I attached an X and a Y to S, okay, and I can retrieve those things, but T does not have them. Okay, so you could, if you wanted to, change things around a little bit. Let's do this. I'm going to quit Python just to clear the boards and come right back in. Watch this. I am X. All right. I'm Y. Look at this. Okay. Oh, look at that. Okay, so I can make, if I make a simple object and I put this code in its body, automatically that simple object will know two things. It will know it's X and it will know it's Y. These are unprotected. I should show you this. T is not changed, but S.x is changed. Okay, so Python has this mechanism. Okay, now I'm going to get a little fancier here, and I'm actually going to write a Python program. So you're learning something about Python classes right now. I'm going to write a program called point. Now, Python doesn't have the same naming convention as Java does, but it's, in general, class names are capitalized in Python. In Python, for class names, we'll use the camel notation where words are set off by capital letters for class names. Whereas for variable names, Python tends to use the snake notation where words are separated by underscores. So let's go ahead and make this class point. Now, I'm going to do some hairy looking things here. All right. This init runs every time I create a new point object, init will run. And I'm going to give it some stuff here. I'm going to say self. Now, what is self? When I am programming and I'm a point, self is me. All right. But I'm also going to go x equals 0, y equals 0. I'm also going to put 2 arguments in here, and I'm going to give them default values. Okay, so these are just like keyword arguments that you stick at the end of a function. Now, my x is x. So whatever values get passed in here, I'm going to stick to myself as y, okay? So when I'm inside this class, self is me. I'm a point. All right. So now let's come down here, and it's that special method init. It's got to have exactly that name. The first argument must be self, but then you can feed it other arguments and do things with them. All right. So here I'm gonna say p is equal to point. Okay, and I'm gonna make a point with empty parentheses. So now I'm gonna print it out. Print format string, and I'm going to say, quote, p is equal to p.x, p.y. All right. Okay. And now I'm going to do this. I'm going to change every p to a q. And I'm going to say q is equal to point. Let's put our friend 3, 4 in there. All right. And let me make sure that that is, okay. I replaced the p with a q and I got crint. That's not going to work. All right, so I fixed that. So let's run this program. Okay. This is my little main routine here. I'm going to go ahead and run this program. Ooh, look at that. So I'm able to print out and store values for a point. Now, let's go ahead and give this a little more capability. So we sort of wandered away from Java for a little bit, but you're going to see that the principles that adhere here are going to adhere in Java as well. We're going to make another function here. And this is not going to be so special. And you can see I'm using snake notation. And I'm a point. Other is also a point. Okay? And I'm going to compute my distance from me to that other point. I'm going to import the math library here because it'll come in handy. Because it will actually save me typing. Good old math.hypot. I'm going to say self.x minus other.x. Self.y minus other.y. Okay. There's my distance too, and I'm going to come down here and print. Let's see, how do I want to do this? Oh yeah, let's just do this. Is equal to. Okay, and p and q are points. And hopefully when I run this, let's see what happens. So Oops. Did I forget to put math in? Drat. Let's fix that. Beautiful. So here's my point P and my point Q. And here's my distance 2. Okay? So that's a little bit about classes in Python. All right. Now, let's do a little comparison between the two languages. Python has classes, but their use is optional because you haven't even used them yet. Now, one thing you're going to see in Java is more modest than Python. All right? Much more modest. There are things that you can do in Python, such as you can import math and type math.py is equal to 4, and you make pi be 4 for your entire session. Java has a math library, but it's not going to allow you to do that. It's got a facility to prevent that called finality. Java and Python both have the same system of boss statements and worker statements. Important differences. 1, Python depends on formatting. Indentation is how you indicate blocks in Python. This is familiar. You make a function, you have to indent one tab stop for the body of the function. In Java, how did we delimit functions? Well, let's take a look. Let's go back to our example.java. You can see that the body of a function is delimited by curly braces. In fact, if you want to, you could do this, and this program would compile. The compiler doesn't care. All it sees is a one-dimensional stream of bytes. It doesn't care. But the human being would rather see this, because you can see the hierarchical way in which the program is organized. Now, some programmers you will see will put the curly brace on the same line as the function header, and that is fine. That's an accepted convention. I call it the flying brace convention. The reason I like this is that if I make a mistake with curly braces, it's really, really easy to see when you do this, because you just look up and see, hey, is there a curly brace lining with that one? One of the worst types of errors in Java is a curly brace error. The error messages are terrible. They'll tell you things like improper type of, start of type, illegal start of type. When you see those error messages, you'll know it's a curly brace problem. Check your curly braces. A lot of editors match for you. If you're using Vim like I do, and you're in command mode, you can hit %. And most editors have an easy way for you. They'll highlight the matching. In fact, Vim actually highlights the matching paren. VS Code does that too. You become familiar with your favorite editor. Okay. So we went ahead. We made the Go class, so we saw a comparison. Now, to make our hello class or our example class executable, here's how you can do it. Let's go ahead and do. We put in this special method main. That makes our class executable. It has exactly that header. And as we go along, I'll be explaining things and they'll get more familiar. So now I can say, make a new example. Okay, that makes brand spanking new example. And then we do just like we did in the interactive prompt. And now when I quit this program, it ran. Okay, it compiled. It runs. Hey, I have morbid curiosity. Do you have morbid curiosity? Here, let's go ahead and see what's in example.class now. Okay, now you see there's more stuff in there. And there's a whole bunch more gibberish. Can you recognize anything? Well, maybe there's one or two things that are recognizable. But by and large, this file, look at it, looks like gibberish, okay? So now you've seen what's happened here. We made our program executable by adding a main, and you can make any Java program executable by adding a main. And what we did in this line, we created an instance of an example object, and then we used its go method. Okay? So that is the very beginning of Java and Python classes. In the next video, we'll go into more detail on these. And we will talk about Java's primitive types. Because Java has 8 primitive types, and we're going to discuss all of those. And so I think I will stop here.